మనం రాసే మిడ్ ఎగ్జామ్లో 2 పార్ట్స్ ఉంటాయి, పార్ట్ ఏ అండ్ పార్ట్ బి. పార్ట్ ఏలో వచ్చేసి 10 మల్టిపుల్ చాయిస్ క్వశ్చన్స్ ఉంటాయి, పార్ట్ బిలో వచ్చేసి డిస్క్రిప్టివ్ క్వశ్చన్స్ ఉంటాయి. మనం ప్రాక్టీస్ చేయబోయేది ఏంటంటే 20 క్వశ్చన్స్ ఫ్రమ్ క్వాంటమ్ మెకానిక్స్, 20 ఫ్రమ్ సెమీకండక్టర్ ఫిజిక్స్ అండ్ నానో టెక్నాలజీ, 10 ఫ్రమ్ కంప్యూటింగ్. ఎగ్జామ్లోకి వచ్చేసి ఫస్ట్ యూనిట్ నుంచి 4, సెకండ్ యూనిట్ నుంచి 4, థర్డ్ యూనిట్ నుంచి 2 ఇస్తారు. మొత్తం 10 for 10 marks. Quantum mechanics law objectives. The de Broglie hypothesis relates which two physical quantities? So de Broglie hypothesis basically ఏం చెప్తుందంటే మ్యాటర్ హ్యాస్ డ్యూయల్ నేచర్ అంటుంది. దాంతోపాటు de Broglie ఈక్వేషన్ ఏంటంటే లాంబ్డా ఈజ్ ఈక్వల్ టు h/p, దట్ ఈస్ ఈక్వల్ టు h/mv, మాస్ ఇంటూ వెలాసిటీ. సో ఇట్ రిలేట్స్ బోత్ వేవ్ లెంత్ అండ్ momentum. This is the answer. The Davison-Germer experiment confirms the dash nature of the electron: particle, wave, electric and magnetic. So Davison-Germer experiment confirms the wave nature of the electron by taking diffraction of the electrons. According to Heisenberg uncertainty principle, we cannot simultaneously know the exact. Those are conjugate parameters where we have position and momentum, then time and energy, then angular momentum and theta. So these are the parameters. In this we have position and momentum as the answer. Then the unit of the wave function psi square is basically psi square. We will use the probability density and psi square will be calculated as psi star psi. Psi star means conjugate. Generally, if psi is a plus psi b, psi star will be a minus ib. That's a conjugate. When we multiply, we will get the real number. That is the Born interpretation. An operator applied to a wave function that gives back the same function multiplied by the constant is called h psi is equal to e psi. It's a Hamiltonian operator. It will give energy and eigenfunction. These type of equations what we call eigenvalue equation. The expectation value gives average value. Schrodinger time independent wave equation is used to describe quantum state of the particles. In the particle in one-dimensional box, the energy levels are quantized. They are not continuous or equal or zero. They are quantized. Bloch theorem applies to. Bloch theorem is applicable whenever electrons are moving in periodic potential, and Bloch function is written as simply the product of periodicity with plane wave. Then Cronin-Penny model explains energy band formation in solids. Effective mass of the electron represents modified mass due to crystal environment. So whenever electron is moving in the crystal, due to the presence of the field, its mass will change. So the effective mass we will calculate there. Energy bands are formed due to overlapping of atomic orbitals. Conductors have no band gap. Band gap is 0 for conductors. For semiconductors, it's a 0.123 electron volts. This is semiconductor. Then if band gap is greater than 3 electron volts, this is what we call insulators. Insulators have, so basically it has a large band gap. Semiconductors at absolute zero act as perfect insulators. Which of the following is a quantum mechanical operator? Momentum is the quantum mechanical operator. So basically operators are shown like this with a cap. The wave function must be, it's a normalizable. The ground state energy of a particle in one-dimensional box is minimum and non-zero. Eigenfunctions of Hermitian operators are orthogonal. Which one is not a postulate of quantum mechanics? Wave function describe the system, operators correspond to observables, energy is always conserved, measurement collapse the wave function. This one, energy is always conserved, is not a postulate of quantum mechanics. Next unit is semiconductor physics. Intrinsic semiconductors are pure semiconductors. Doping in semiconductor increases electrical conductivity. In n-type semiconductors, majority charge carriers are n-type electrons are majority charge carriers. In p-type, holes are majority charge carriers. Direct band gap semiconductors are preferred for lighting and LEDs, direct band gap semiconductors. The Hall effect measures carrier concentration and it measures a magnetic field also. A PN junction diode conducts current in. Generally, if we consider ideal case, in the scenario of ideal case, it's only forward bias only. But when we take a real, it is both forward and reverse direction. So generally we will go with real ones. That's why we will take both directions it will conduct. LED emit the light when forward biased. So LEDs won't work in reverse bias. LED stands for light emitting diode. Solar cells works on photovoltaic effect. So photovoltaic effect is the basic principle of solar cell. For LED, electroluminescence is the principle. Nanomaterials have size range of 1 nanometer to 100 nanometers. Means any one dimension of a material is within 1 to 100 nanometers. Those materials are called nanomaterials. Quantum confinement effect becomes significant when particle size is less than 100 nanometers. Surface area to volume ratio in nanoparticles is very high. So whenever we reduce the particle size, surface to volume ratio increases. Zero dimension nanomaterials are quantum dots. Ball milling is a top down method, whereas sol gel is a bottom up method. Sol gel method involves liquid precursors. Precursor means a starting material. XRD is used for measuring crystallography. Scanning electron microscope gives information about surface morphology. It will provide the surface morphology of a materials. Nanomaterials are widely used in electronics and medicine. Indirect band gap semiconductor emit light. Not at all. They won't emit the light. Only direct band gap materials emit the light. Doping silicon with boron produces p-type semiconductor. Electrical conductivity of semiconductors dash with the temperature. As the temperature increases, electrical conductivity of semiconductor increases, but when come to conductors, it decreases. Next chapter is quantum computing. A qubit can be both 0 and 1 simultaneously. The mathematical space of qubit is called Hilbert space. Hilbert space is the space where quantum state exists. Bracket notation is used in. This is what we call bracket notation, and this is mostly used in quantum computing. Superposition means a qubit can have two values at once. That is what we call superposition. Entanglement is a phenomena where two qubits remain correlated. If we tune one, another one get affected. A classical bit is either 0 or 1. It's a normal computer system. Bloch sphere is representation of qubit states. So Bloch sphere is used to represent a qubits. Multiple qubit systems is capable of complex parallel computations. That is the main advantage of this quantum computing. Quantum computers outperform classical computers in certain complex calculations, where for conventional computer it takes longer time, but here it will take less time. Dirac notation uses symbols like this one, right? That's all for this part A, and all the best for your exams. Thank you.